Hello friends, I am Dr. Kalpesh Amrutkar, Assistant Professor in Department of Statistics, KRT Arts, BH Commerce and AM Science, which is popularly known as KTHM College, Nasik. Welcome to the T.Y.B.Sc Statistics class. I am going to teach you Paper 1 Distribution Theory. Firstly, what is meant by distribution? So distribution of a statistical data set is a listing or function showing all the possible values or intervals of the data and how often they occur. You have already gone through various distribution, uh, which is discrete or continuous. Also, you might be aware of concept of random variable, its expectation, variance, standard deviation, quartiles, nature of distribution, etc. In this course, we will go through some continuous distribution like beta distribution, Cauchy distribution, Weibull distribution, Laplace distribution, log normal distribution, bivariate normal distribution. Also, in this paper, we will see the order statistics. Before going to start this course, we will write the some basic which will useful throughout the course. Now mathematical background. First one is gamma n, which is equal to n minus 1 into gamma n minus 1, which is also equal to n minus 1 into n minus 2 into gamma n minus 2, which is also equal to n minus 1 into n minus 2 into n minus 3 gamma n minus 3. In this way, we can write n minus 1 into n minus 2 into n minus 3 and so on 2 into 1 into gamma 1. We know that gamma 1 is equal to 0 factorial and 0 factorial is nothing but 1. Therefore, gamma n is n minus 1 factorial. If I have to put n is equal to 1 by 2, then we get gamma 1 by 2 is equal to square root of pi. This is improper integer which you can see in the F.Y.B.Sc or S.Y.B.Sc calculus paper in mathematics. Friends, in this lecture, we will focus on the beta function. There are two types of beta function. Out of this, one is beta AB is equal to integration over 0 to 1 x raised to a minus 1 minus x raised to b minus 1 dx, where a and b are positive and x is lies between 0 to 1. For example, if I have to put a is equal to 3 and b is equal to 4, we get integration over 0 to 1 x raised to 3 minus 1 1 minus x raised to 4 minus 1 dx is equal to beta 3 4. Here I have just replaced the a by 3 and b by 4. So we get the this form. Another form of the beta function is beta ab is equal to integration over 0 to infinity x raised to a minus 1 divided by 1 minus x raised to a plus b dx, where a and b are greater than 0 and x is lies between 0 to infinity. Is it clear? So in the first form of the beta function, range of x is 0 to 1, and another form of the beta function is range over x is 0 to infinity. Further, we will see the some basic properties of beta function. So whatever the value of a, I have fixed the b, that is b is equal to 1, then we get the beta a1. In the first form we get 1 upon a, where a is greater than 0. Same way, if I have to fix the a and whatever the value of b, we get beta 1b is equal to 1 upon b, where b is greater than 0. Another property of beta distribution is symmetricity. That means beta ab is equal to beta ba, where a and b lies between 0 to infinity, or a and b strictly greater than 0. This is the symmetricity property of beta distribution. One more interesting property of beta function is beta AB is equal to gamma A into gamma B divided by gamma A plus B. This is just the relationship between beta function and gamma function. Or you can write this gamma A as A minus 1 factorial. Gamma B is B minus 1 factorial. So gamma A plus B is A plus B minus 1 factorial. Particularly, if I have to put the A is equal to 1 by 2 and B is equal to 1 by 2. So we get beta 1 by 2. 1 by 2 is gamma 1 by 2, gamma 1 by 2. I have just replaced the A by 1 by 2 and B by 1 by 2. So which is gamma 1 by 2 into gamma 1 by 2 divided by gamma 1 by 2 plus 1 by 2. So we know that gamma 1 by 2 is square root of pi, gamma 1 by 2 is square root of pi, and divided by gamma 1 by 2 plus 1 by 2 is 1, so gamma 1. And we know that gamma 1 is 0 factorial, which is nothing but 1. So square root of pi multiplied by square root of pi is pi. This is the very interesting result of beta function. So this is just the background, some mathematical background which we need for the overall course. So now we will go to the beta distribution of first kind. So beta distribution of first kind is the applicable in the Bayesian inference or statistical inference. That case we will use the beta distribution of first kind. The more application of the beta distribution I will discuss in the last lecture of the beta distribution unit. So firstly, we will see the definition of beta distribution of first kind. A random variable x is said to follow beta distribution of first kind with parameters m, n if its probability density function is given by f of x is equal to 1 upon beta mn x raised to m minus 1, 1 minus x raised to n minus 1, where n is positive and x is lies between 0 to 1, 0 otherwise. And the notation of the beta distribution of first kind is x random variable x follows beta first kind m comma n. There is a two parameter in the beta distribution because already we have seen the beta function. There is a two values a and b. So here again there is a two parameter m and n. Now we will see the mean of beta distribution, or how to find the mean of beta distribution of first kind. So we know that mean of continuous random variable is equal to expected value of x, which is integration over x into fx dx. Here f of x is 1 upon beta mn x raised to m minus 1, 1 minus x raised to n minus 1. So expected value of x is integration over 0 to 1 x into 1 upon beta mn x raised to m minus 1, 1 minus x raised to n minus 1 dx, which is equal to 1 upon beta mn integration over 0 to 1 x into x raised to m minus 1, 1 minus x raised to n minus 1 dx, where 1 upon beta mn is a constant which is outside the integration side. Further, the 1 upon beta mn is as it is, integration over 0 to 1, here x raised to m minus 1 plus this 1. So this is x raised to m plus 1 minus 1, 1 minus x raised to n minus 1 dx. Now we know that integration over 0 to 1 x raised to m minus 1, 1 minus x raised to n minus 1 dx is beta mn. So here the m is replaced by m plus 1, so we get this integration is beta m plus 1 comma n. So 1 upon beta mn into beta m plus 1 comma n. So by a relationship between beta function and gamma function, the beta mn is equal to gamma n divided by gamma m plus n. So here beta m plus 1 n is gamma m plus 1 gamma n divided by gamma m plus n plus 1, and 1 upon gamma n divided by gamma m plus n. So denominator of denominator is numerator. So here I have just write in this way, we get this gamma m plus n divided by gamma m into gamma m. Okay, this denominator of denominator is numerator, so this gamma m plus 1 is numerator side and this denominator is as it is. Also we know that gamma n is equal to n minus 1 into gamma n minus 1. So gamma m plus 1 is m into gamma m and gamma n is as it is. Again denominator is gamma m plus n plus 1, so which is you can write in the m plus n into gamma m plus n. So this gamma m plus n is cancelled with this numerator side. This gamma m into gamma n is also cancelled in the denominator side. So this is the just expectation of beta distribution of first kind is m upon m plus n. Only the remaining part is m upon m plus n. So this is the your mean of the beta distribution of first kind. Okay. Further, we will see the variance of the beta distribution of first kind. So we know that the variance of random variable x is equal to expected value of x square minus expected value of x bracket square. This is the variance of your continuous random variable. So we have the expected value of x, which is already we will find out now. We will find the expected value of x square, which is not known, or we will find it for the computing the variance of x. So again, by definition of expectation, expected value of x square is equal to integration over x square into f of x dx. So here f of x is 1 upon beta mn x raised to m minus 1, 1 minus x raised to n minus 1. Therefore, expected value of x square is integration over 0 to 1 x square 1 upon beta mn x raised to m minus 1, 1 minus x raised to n minus 1 dx. I have outside the constant in the integral sign, then we get 1 upon beta mn integration over 0 to 1 x square x raised to m minus 1, 1 minus x raised to n minus 1 dx. Further, this 1 upon beta mn is as it is integration over 0 to 1 x raised to m minus 1 plus 2 and 1 minus x raised to n minus 1 as it is into dx. Also, we know that beta mn is equal to integration over 0 to 1 x raised to m minus 1, 1 minus x raised to n minus 1 dx. So here m is replaced by m plus 2. So 1 upon beta mn into beta m plus 2 n. So I have just write the beta function in the form of the gamma function. So gamma m plus 2 gamma n divided by gamma m plus n plus 2, since beta mn is equal to gamma m into gamma n divided by gamma m plus n. Again 1 upon beta mn is 1 upon gamma m into gamma n divided by gamma m plus n. Again the denominator of denominator is numerator, so therefore it can be write as gamma m plus n divided by gamma m into gamma n. And here I have just used the gamma n is equal to n minus 1 into gamma n minus 1. So here gamma m plus 2 is m plus 1 into gamma m plus 1. Again I have write gamma m plus 1 in the form of m into gamma m. Similar way we can write the gamma m plus n plus 2 is m plus n plus 1 into m plus n into gamma m plus n. So this gamma m plus 1 is cancelled with this gamma m, and gamma n is cancelled. So only remaining part is m into m plus 1 divided by m plus n plus 1 into m plus n. This is your expected value of x square. And we know that the expected value of x is m upon m plus n. So our variance is variance of x is equal to expected value of x square minus expected value of x whole square. So expected value of x square is m upon m plus 1 divided by m plus n into m plus n plus 1 minus this expectation is m upon m plus n, so that square is m square upon m plus n square. So I have just solve this. Firstly, I have just the common the denominator part, that is m plus n square upon m plus n plus 1. Here m plus n into m plus n plus 1. I have here the multiply the m plus n and divide the m plus n. So m into m plus 1 into m plus n minus m square into this side I have multiply and divide here. So m plus n plus 1 is good. And then I have solved these brackets. We get the m square plus m and m plus n is as it is minus m cube m square into n m square. This is the negative sign outside this bracket, so this negative sign is the each term. Again I have solved this bracket, so m square into m, that is m cube, m square into n, m square, m into n is mn minus m cube minus m square into n minus m square, and denominator is as it is. Okay, so I have cancelled the terms with the positive and negative sign. So m cube is cancelled with m cube, m square into n cancel m square, m square is cancel. Only remaining part is mn in the denominator, and in the numerator, and denominator is m plus n bracket square upon into m plus n plus 1. So this is the just remaining part. So variance of x is equal to m into n divided by m plus n bracket square into m plus n plus 1. This is the variance of beta distribution of first kind. So in the next lecture we will see the how to find the earth moment of beta distribution of first kind, their expression and some relationship between this. So in this lecture we have seen the some basic formulae which we will use throughout the course, and see the PDF of beta distribution of first kind, their mean and variance. Okay.